Hi. Hey, Zach. How are you?
Very good. Very good. Nice
Yeah.
to see you.
Yeah. Good chatting here. Hey, we just did the TechStrong survey about Edge AI, and we got a lot of interesting ideas that came out of that, and a lot of good responses from customers, right? One thing that stuck to me, right? Like we will go through the three data points, right? Like one was about performance concerns, infrastructure cost, and then the operating expense, right? I'll start with the performance concerns. 51% of the respondents are worried about performance moving AI from the cloud to the edge. You started I believe the first edge AI foray back in 2015, 2016 for DARPA, right? When you started research around that, was performance a concern for you?
Performance has always been there, right? I think the expectation have definitely changed over time. These days, right, you have your bigger and large language models and things like that. People are hooked on to those kind of applications. There's a lot of value that it brings, but you know, you're never satisfied with the kind of compute that you have. You're never satisfied with the amount of memory you ever have. The application capability continues to rise up. So the compute is always needed, and there's always more that you want. But there's a ways around it that you can satisfy what is kind of growing in terms of the application space, right? So it's there and it will continue to change. I don't think it will ever stop. Yeah.
Got it. No, then double clicking on performance, right? Like if I'm getting a certain level of accuracy, certain level of throughput for my recommendations or for my predictions up in a large cluster, cloud cluster, um, should I be worried when I move to the edge? Will I get the same performance, or should I be worried about that, or should I be thinking about a different calculus as I'm shifting my workloads?
Yeah, no, I think some of the things that you push out in terms of the idea of edge continuum, right? That it is a continuum of compute, a continuum of availability on network and things like that. That the edge itself is not just one destination, but anywhere along the side outside of cloud, right? And you
Yeah.
famously kind of coined it where, let's be opportunistic about putting where the compute makes sense, therefore giving the type of performance and expectation on the applications, right? And maybe you can even dig deeper into how you're already helping folks on that end.
Got it. Got it. Yeah, yeah. When we coined that edge continuum, I don't think anybody was thinking about it, and we saw the data flow, and we saw the compute distribution along that network, and we were like, why do we need to only deploy models either at the source or at the destination? Why not along the pathway, right?
Right.
And having a heterogeneous set of hardware, you need an architecture, you need a mindset, right? It is not about just doing it. You need to be very deliberate about this architecture of how do we distribute this, right? So very good point there, right? So let me from a technology point of view, right? Like we've done this when we are continuing to do this for DoD. As we think about it, how should we be like as an industry in itself, right? Like how should we be thinking about AI in a distributed manner? We talked about edge continuum. It's a great concept, and it will take some time for it to get implemented. But distributed computing is something that people are familiar with. How do you see the pairing of distributed computing to edge continuum? The sensor to server story and a distributed compute infrastructure. And how would you, from a technology perspective, as a technologist, right? Like how do you see that, and how does the performance concerns that the customers have, right? Like is this a one step in between before they get to the edge continuum? Love to hear your thoughts.
Yeah, that's a very kind of interesting thought and many different ways to kind of address it, right? And one way is to think about that, cloud is a centralized compute. You put everything all in one place because you expect things to happen all in one place. there it itself then is the kind of bottleneck because then you need to funnel everything to that central compute, right? And a central holding place. Uh, Now then you look at the other side and say, okay, where is this data coming from? It's coming from everywhere, A. B, you have sensors that are, in fact, everywhere. The sensors themselves are distributed. You don't have camera on one place, but you have cameras in many different places. You may have audio sensors in many different places, right? So sensors themselves are distributed, and yet compute is all centralized, right? So then you say, okay, maybe we ought to break that thought process where if you are then producing the data in your distributed sensor, put the compute there. Therefore, that distributed compute nature. That itself, people are starting to do. The compute at the sensors are getting more capable, and you are able to do more at the source of the data. And therefore, then that mindset about how you want to build applications and how you would then distribute that computing makes sense because the distributed sensors themselves are getting more intelligent, and you want to put some smarts around it, right?
Yeah, that's a great point, right? So I think one thing that people shouldn't miss is that with every distributed compute that you put in, there is an additional OpEx that goes with it that people don't think about, right? The pundits that sit in analyst rooms and stuff, they talk about, right, like, oh yeah, do this, do that, and stuff, but they forget the cost associated with this. I think one of our customers clearly talked about, right? If I have an edge device, like let's say a small compute processor that is distributed across the 20 or 60 odd cameras that they have in their plant, each one needs to be housed, networked, powered, and properly maintained and cared for over their life cycle, which adds additional costs. But at the same time, if I'm able to route all of that, the 60 odd cameras to a single server on the factory floor, it is not going too far away. It is still in the factory floor in the closet. And I can run a network cable to that, which is already networked, and I can get that going. I'm still able to achieve my edge computing. It is distributed in the sense of I have distribution in the plant floor rather than distribution at the sensor level. Right, that is a key factor that people need to consider when they're
Yeah,
thinking about this.
I definitely agree. Like, there's always the different level of fidelity in terms of your network, your compute, right? Even your sensor type, right? For example. So if you think about networking, you can do your Wi-Fi, you can do your Zigbee, Bluetooth, different level of performance and capability there. And then you go up a
Yeah,
little bit and say, okay, maybe it's a 5G network, and that gives you a different kind of scope and scale. Think about compute as well. We can be as small as something that's worn, body worn, and what have you.
yeah,
But you can also scale up to a laptop size and things, right? So all of that is within what you have already said, the edge continuum, where, right, a blending of the network capability and scale, and also the compute and scale.
yeah. So I think we are already hitting upon this infrastructure cost that, which is the second data point that we got out of this survey, right?
Mhm.
40% of them are worried about the infrastructure costs. Right. So we talked about this distributed compute. We talked about, it's not just sensor level, but you can actually push it down to a server as well within the time frame, right? And then I think we are automatically hitting on this operating expense envelope as well. 37% of respondents are like, worried about the OpEx of moving to the edge, right? If you remember, we were talking to this QSR company back in the day, and they were trying to do edge AI, but they doing AI in their restaurants, but they were trying to pump all that data to the cloud, and they had what 2,000 plus restaurants, and the amount they calculated, the OpEx literally made the project non-viable to get started. Right? They had what like 4 or 5 cameras streaming 4 or 5 cameras on a not to 24/7 but almost equivalent of 6 days or 7 days and 10 to 12 hours a day you're streaming that information, and you're trying to do the processing in a cloud-like environment, it is not going to be you're paying for the bandwidth, you're paying for the compute and unnecessary data storage. I remember, when we were talking early days, we talked about, how the IP got started from a DARPA initiative. When we are flying in over a desert, why do I need to send pixel information of all the brown sand that I see, right? Why do I need to send hours and hours of footage of brown sand when I just need that one red pickup or that yellow car that's going? That's the only information that I need. Why do I need to keep transmitting, right? So that concept comes into from a military use case to the commercial use case, right? Like most surveillance scenes, most use cases, the scene doesn't change. There is not much activity that's going on that you need to be recording and saving things. How do I be intelligent about it?
Yes,
Right?
exactly. And I think as we talk to customers, we are seeing that same storyline, right? That common aspect where the developers, the enterprise try to build that prototype. They got the concept out there. It works beautifully and it says, okay, I believe in this story. I know I want to go deploy, but I can't scale it up. I think those are the scaling questions, right? Where it is not just that you made it work, but now
Yeah,
you want to now make it now run across the enterprise, across all the distributed offices that you have and locations, right? Therefore, the distributed nature, the cost involved, the OpEx, right, becomes a scaling issue. And those are the things that we have already thought about with respect to how we want to do hybrid level edge continuum rollout of any of these edge AIs.
absolutely. Right. So there are two more threads that we can pull on this, right? One is brownfield opportunities and then greenfield opportunities. Um, the way I define brownfield is existing use cases that are being underserved by discrete compute or deterministic compute, right? Your rule-based algorithms, rule-based programs that are only providing you so much value. That can be, you can unlock some potential over there by addressing those using AI. And then you have the second use cases, which is greenfield, completely nobody thought of before, because without AI, there was no way possible that they could be done. And here we are, right? Like with the advent of AI and the way we are approaching things, those use cases can be unlocked and they can scale the economies as well, right?
Yeah, not only scaling to kind of new application and enabling kind of new features and things like that. A lot of enterprises have already committed on hardware, right? Saying, oh, I already have installed this. Now I want to do more.
Mhm.
The tendency is then go, let's put more hardware on it because I have this AI workload, right? I've already committed to these, enterprise level server and hardware that I've already bought. In order to get that new capability, AI and what have you, I need to go now buy more hardware. But in fact, that's a fallacy in that there may be more capability they can take out of that hardware by optimizing the workload itself. So without
Yes.
committing more resources, you can actually still enable it by optimizing the workload to run on the existing hardware. Right?
Absolutely, absolutely. I remember, the previous project that I did, right? Automating audio, human hearing, right? So we had a use case where this is a this I would put it in the greenfield use case, right?
Mhm.
Um, Oil and gas company or actually a factory that gets fuel supply. Okay, they get fuel supply, and they load this fuel in a large tanker. There is no gauge or there is no sensor to tell them the level of the fuel because it's such a large thing. They don't know when they need to replenish it, when they're running low, when they need to stop. None of that. It's basically like weekly there is a truck comes and then they load it and go. It's a sunk cost, right? It's not cheap. It's like, multiple tens of thousands of dollars to fill the tanker, and it is sunk cost.
Mhm.
So the use case that we were looking at there was like, can we use sound, because sound gives you a clear indication of what is the level of the fluid within the tanker,
Right.
right? So in that case, an edge computing, edge AI solution is the ultimate winner over there, because you can do this with with $100, $200 hardware,
Mhm.
right? And then a few $1,000s of software for an annual subscription. You can actually get a notification of what is the level of the tanker. That uh, business intelligence will save thousands of dollars in interest and stuck capital that can be utilized elsewhere, and you can optimize your supply chain effectively, right? So
Definitely.
this is like a case of a legacy industry using a greenfield opportunity using edge AI.
Yeah, and many other applications that we are unlocking today, right? Both
Yeah,
in the defense side and also in the private sector as well, as you say. Even on the let's say on the federal side, right? We're looking at wearable type computing, right? Fitbits and what have you. You can put AI on there. You can check for health and what have you, how stressed anybody would be in any scenario. That that is one level of edge AI that you can compute on. That information can then transfer to maybe a central hub for a collection of number of users, and you can then find analytics about that scenario for that group of persons, and then you can aggregate that up. So again, back to the edge continuum story, a lot of different ways where at the edge, sensor edge, you're doing some compute and doing some analytics and get deriving value from it.
yeah,
And then you can go up to the next level and then derive other values, right, at that level.
absolutely, absolutely. So let's talk a little bit about brownfield opportunities, right? Like I think you have consulted on several embedded compute and AI related work, both at SRI and also, prior to that, in computer vision related activities in other companies that you worked at, right? Uh, how do you see the value um, deep learning and AI bring where computer vision has failed?
Elaborate a little bit so that I can kind of address that.
So your legacy CV, open
Mm.
CV type applications, right? Like where has when is open CV good enough to proceed versus when do we need a deep learning and when do we need edge AI related, like things that Latent AI supports, right? Like where does that come in?
Yeah, that's actually a very good question. And, computer vision has grown in a way that, the AI side of things kind of took over. Computer vision itself is continuing, right? There's more derived analytics, more contextual level that are still being worked on. So there's still an active research per se. Now, where does it fail and all that? Instead of addressing directly that, you say, where are the opportunities that happen now with AI? In the very, very early days, everything was feature oriented. You hand coded all your features. It kind of worked and it works at a certain level. With AI, you are now everything is data driven in the sense that you don't go in and codify your features and things that you want to detect, right? The AI algorithm would generalize and figure it out. And therefore, with that kind of workflow, you tend to catch more of those corner cases, right? You have computer vision, it works, but then the corner cases you don't know about. But given enough data and the right kind of training method, you're not able to cover not only the things you worry about, but things that are a little bit outside so that it is a little bit more robust. So computer vision has been a little bit more robust. Going further then from there, saying, okay, I have computer vision, it is kind of robust. People are now starting adding more context, right? How does this relate to that scene? Does it make sense to have this versus that? So contextually, how does the environment look like? And a little bit of intelligence about, what is normal and abnormal kind of context to give you that sense. So all of the large language models, the language models coupled with computer vision, those start to then think about not just the ability to detect maybe the person, but the person in the context in the scene. So a lot more that can be done there, and a lot then can be applied to that AI.
Got it. So you span the world from OpenCV and the legacy computer vision down to now. You're one of the leading experts on deep learning and an embedded compute perspective from an AI at the edge, right? How do you see folks that are transitioning from OpenCV to deep learning? What are the challenges that they face today? Or they're facing?
A lot of challenges are then understanding the ability to deploy. So again, back to the notion that you can build a prototype and it works really well. It may work well even in a lab setting and maybe in a very uh, kind of built up scenario, let's say in the field, it kind of works. The hard part is then scaling it across large distributed kind of computer vision solutions, right? It's not just one camera, hundreds of cameras, thousands of cameras. It's not just one sensor, but many sensors, right? And then to be able to reason through that. Those are the things that are now challenging in terms of addressing it. Now, to address that, then you need to be able to then build tools to build those things out, to deploy them in a way that you can manage the number of edge AI solutions out there. So those are the things that we at Latent AI are dealing with, the practical aspect of said computer vision or said AI solutions that are prototyped.
Got it. Got it. So, we talked about deterministic versus non-deterministic, right? So, can I assume that, or actually OpenCV type is more deterministic because you're feature driven and with the known features that you're going after versus, non-deterministic, it's patterns and, the data is driving the decision rather than the knowledge of the programmer or the user that is coding it, right? So, given these two challenges, right? Like in deterministic, you can easily test what you're looking for, right? And what you're not looking for, it's easily derivable. But then the moment you come into this world of AI using deep learning and your test becomes a challenge.
Mhm.
And also determining what is the right model, what is the right hardware, how do I right size this, right? Like how would you help if you were to mentor somebody, how would you help them overcome that challenge?
No, that's a very good question, right? With respect to the accuracy and things like that, you can have large models that you build, or you have small models. You can do specialized models or very generic models. Those are all design trade-offs within the edge AI kind of world, because that couples in with how you want to deploy it. You may say, I overprescribe everything and I put the biggest computer out there because I wanted to cover everything, but then you have the scaling issues about costs and things like that. The things that we have studied on that survey, right, tells you exactly that. We tend to know how to build something, but not how to scale it. So when I mentor other folks and things like that, we think about the end, right? Where do you want to get to, and not just where you are, from a prototyping perspective. Yes, you want to build it, you want to build it to some level. Is it computer vision, open CV type things, or is it AI kind of centered thing, deterministic or not? You're still statistically relevant in terms of your accuracy. So you can actually bound your tests and understanding how it performs in the field. But knowing the end kind of talks about then the life cycle of that model. A lot of people, I think, when they go out and say, I'm going to build and deploy an edge AI solution, they think of it as a one-off, right? I build it and out it goes, and if for the lifetime of that model, is going to work perfectly. But in fact, and things that we work on at Latent AI is think about the life cycle. That in fact, when you push it out, over time, you're going to collect more data, and you realize that you may need to update those model. Okay, what are the tools and infrastructure that allowed you to then update the model? Would you know that model is your version 1 or version 10 of that deployed state? If you have a distributed nature, and we talked about having things in the edge continuum, where is all my models and what versions are out there and all that? Those are things that are now, as you scale up, uh, coming up with more interesting kind of complexity, right? And having then a good reason, good thinking about where you want to end up becomes important. So as you build anything out, think about how it would scale. Yeah.
Excellent, excellent, excellent. Um, it's a very fascinating area, right? Like when you go from deterministic to non-deterministic, there are things that you need to consider that you've never considered before, right? It's not like putting an if-then loop or if-then else and then calling it AI, right? A lot of people are doing that or have been doing that so far.
Sure.
So let's change gears a little bit, right? Now, as OpenCV and as embedded engineering, right? Like in the past, people never thought about security as part of their job. Engineers never thought security as part of their job. They did something, they threw it over, and somebody else took care of the security aspects of it, right? Like, in physical stuff, you have a security guard standing outside, and he or she was responsible for the security of the premises, and did whatever you want inside, right? So that mindset is shifting, right? Like DevSecOps is a new terminology. It has been like, gaining steam. Now coming into the ML ops side of things, I think there is less talk about MLSecOps. How do we are doing some really cool things in the security aspects of ML security and on the ML ops side. Love to hear, there is a history behind the MLSecOps that we came up with, right? Love to hear that in your own words and educate me.
Yeah, yeah. And Jack, you come from the security kind of angle from your past experience. So
Yeah,
you definitely in your blood, in your kind of veins, that security has to be forefront, right? Especially when we
yeah,
say, hey, I have this AI, I'm going to distribute it now. It's going to be everywhere. What does that mean from a security perspective? So I'm sure you have a lot of perspective there. And
yeah,
I can give a little bit on the technology side, right? The analogy that we tend to make, for example, is the reference, let's say, back to imagery. We collect images, we take pictures, right? We take videos today, right? So images will be JPEG kind of images, video, MPEG, right? And each one of them, for example, we can watermark. We can say, this is mine. We can encrypt those things, right? So think of then AI as a representation of information, knowledge, right? Because you use that to, for example, detect a car, a person. You kind of identify features in the face, eyes, nose, and things like that. So it's a representation, much like how pixels and videos are representation. If you have that representation, then you can obviously annotate it for watermarking, for example. You can watermark an AI model that says this is uniquely mine. You can encrypt it so that it's safe. So those are the things that minimally we think we need to put into a model, not just that you have an AI model, but is actually safe and secure, much like how we think of other medias that we are more aware of and are using today, right? And you go beyond that from just saying this is now tagged and I know where it's coming from, but how is it used within that ecosystem, greenfield or brownfield, right? Because you need to know where it came from, not that you just install any AI into your system. Where did it actually come from, and is it from a trusted source? All those security aspects becomes important. Yeah.
absolutely. Right. I think when we started the company, we talked about security should not be an afterthought. It needs to be built in. It shouldn't be a bolt-on solution, right? I think we were very clear on that strategy from day one. I believe, I remember working at HP, last decade. We had a vulnerability that was introduced in the supply chain by one of our hardware suppliers, right? This was like if we did not have security built in, and if we did not, then that vulnerability, that backdoor, would have gone out to thousands of customers, unsuspecting customers, and without our knowledge as well, right? Like though that is when, like, those are the lessons that you learn that sticks with you, right? You don't want to be in the front page of a newspaper or on a news site, right? So how do we, with what we have done with our MLSecOps, if we may call it, right? Encrypting the model, watermarking the model, having the provenance checks, right? Like we can help all the AI engineers, all AI infrastructure teams that are building out models, we can prevent them from appearing on the front pages for a breach, right? AI hacking is still a new field yet, right? Like there is not many news items out there, but as this becomes prevalent and predominant across compute, the attack surface increases and the hacking will continue, will
Yeah.
increase too.
And we talk to customers, right? And a different perspective from just security oriented kind of
Yeah,
discussion. Some of the customers that we talk to are worried about branding, right?
yeah,
You spend so much money to build this model, let's say a language model, whatever. It takes time to build it, resources. You committed so much money to it. How do you protect that? A, it's an IP thing. And B, if it's cloned and somebody else uses it and that damages your brand. So as any developer come in, it's not just that you want to secure and all that, but it's also affecting your company, affecting your brand.
your brand.
When customers and developers themselves realizes, oh, this has more impact than just say the AI itself, but impacts everything about the company, branding wise, for example, then people keep that in mind. AI with security is going to be an important thing.
So I want to bring it home with the last discussion point, right? Like we've had, as we bring AI to the edge is heterogeneous. You have so many different hardware vendors, hardware processors available, and there are so many open source tooling available as well. None of them go to the depth that a customer needs and wants. And it doesn't take them end to end from a flow perspective, right? Like they are still, I think we've heard several customers talk about this in terms of, I need to do 70% of the work while 30% is what is provided, or the documentation is so dense that I'm not able to get through with it. And I think one of the vendors came to us and talked to one of the hardware vendors, right? Like they said, like, oh, you need a PhD to use our tooling, right? So things like that, right? Like how do we help our folks in the industry to overcome this?
Yeah, that's a big question. A lot of things can be done, right? Think of AI itself, right? AI it's a hard thing, right? It's not that everybody goes in and it kind of comes up with that. There's some folks that builds it, and that's good. And people can now build on top of what people have already established, foundation models and things like that, right? Then you say not only AI, I'm going to throw in the edge on it. You have hardware concerns and all that. That becomes then edge AI a little bit harder, right? Not only are you dealing with model accuracy and what have you, you say, well, can it run on that said hardware? And I'm going to deploy it in a way that is distributed. So more complexity there. What we try to do then is say making things a little bit more engineering based rather than black art or science, right? Meaning I still have to kind of figure out, does the magic work here in my AI and does the magic work on the edge itself? But to be able to then build that workflow much more like an engineering flow, providing information, in providing recipes, things that are more systematic and robust. And once you get to that, you can build AI and AI runtimes without worrying too much about the edge hardware nuances, without worrying about the network nuances. That, in fact, much like how, for example, think about Java, right? Where in the very beginning, oh, it's so complicated, blah, blah, blah. But today, it's pervasive. You have abstracted a lot of the complexity away. And if you can do that for AI and especially edge AI, then you have done it. Where you are codifying and you're building these AI model without worrying too much about all the other things that are in there. You focus on what you are kind of uniquely tuned to do, right? Building the AI out.